Hi everyone, my name is Portia Wang, and in this talk I will be presenting our work titled Socially Late, Virtually Present, the Effects of Transforming Asynchronous Social Interactions in Virtual Reality. This work was done at the Virtual Human Interaction Lab at Stanford University in collaboration with Mark Miller, Anna Queiroz, and Jeremy Bailenson. Virtual reality enables social interactions beyond what is possible through traditional media. In contrast to video conferencing, VR allows users to engage in more realistic social interactions by communicating nonverbally through eye gaze, hand gesture, and proxemics. Additionally, VR also allows users to view immersive scenes at novel viewpoints by simply rotating and moving their heads and bodies. Both factors, namely the nonverbal behavior as well as the ability to view immersive scenes through natural movements, have been shown to increase presence, the sense of being there. While social VR is typically synchronous in that people are all interacting in real time, most media we use today are asynchronous. For example, email and text exchanges, chat rooms, video sharing software such as TikTok are all built around the notion that people can see content after it was posted. The importance of asynchronous communication lies in its ability to bridge temporal and spatial gaps, allowing individuals to engage and revisit content in social conversations at locations and times that are convenient for them. Because of this, we see potential for asynchronous social VR, where we could combine the convenience of asynchronous communication with the high social presence of VR. Using asynchronous social VR, a student who missed out on a group discussion due to time zone differences can leverage this technology to engage with the recorded social interactions as if they were occurring in real time. Similarly, we also see a future where remote employees can attend past group meetings and social VR users in low-traffic time zones can experience crowds. However, despite these potential benefits, it is not clear how we can design efficient and engaging asynchronous social VR experiences. Simply placing new users into reconstructed environments can lead to the feeling of being a fly on the wall as opposed to an assimilated member of the social group. These users will likely find themselves spatially excluded from the recorded group and receiving very little attention from the members of the group. In this paper, we study belated guests, people who can join recorded social VR interactions. Specifically, we were interested in understanding how belated guests perceive asynchronous social VR, and further how transformations of nonverbal behavior in recorded interactions influence user behavior. To do this, we took group discussions recorded through the social VR platform Engage and transformed their tracking data around proxemics and gaze. From the recorded discussions, we derived 4 conditions that varied in the type and amount of nonverbal transformations, namely unmodified, spatially accommodated with added gaze, and finally close range and spatially accommodated with added gaze. Though I will be giving a high-level description of each of the conditions, note that the specific technical implementations for the nonverbal transformations were detailed in our previous poster paper. In the unmodified condition, the new user observed the recordings as a bystander standing away from the group. In the spatially accommodated condition, we place the new user as part of the circle formed by the recorded avatars, all while maintaining the same interpersonal distance from the original group discussion. In the spatially accommodated with added gaze condition, we took the transformations from the previous condition and further inserted gaze from each of the recorded avatars towards the new user. We inserted gaze in a bottom-up manner by sampling and referencing the existing gaze behaviors in the recordings. The amount of gaze added was chosen in a top-down manner through piloting different amounts of inserted gaze. In the example schematic shown on the left, red circles denote positions of avatars with gaze manipulations. Finally, in the close range and spatially accommodated with added gaze condition, we further transformed the previous condition by spatially accommodating the new user at a closer interpersonal distance while ensuring that the interpersonal distance remained within the social zone based on Hall's proxemics theory. Similar to the previous condition, we again inserted gaze from the recorded avatars towards the new user. To understand how users perceive these transformations of asynchronous social interactions in VR, we conducted a between-participant user study with 128 participants. Each participant was randomly assigned to one of the 4 conditions. User study sessions took approximately 45 minutes to an hour to complete, where each participant watched 2 asynchronous recordings in the same condition. We collected different measurements throughout the study. In the pre-VR questionnaire, participants were asked about their demographics, previous experiences, and opinions on the discussion topics. During each of the asynchronous recordings, we tracked the position and rotation of the head and hands at 30 Hz. After the participant has watched each of these recordings, we collected responses to open-ended recall questions on the content of the recordings, as well as the participants' opinions on the discussion topics. Finally, in the post-VR questionnaire, we asked participants questions on presence, perceived attention, perceived threat, social attraction, and items used for manipulation checks. Our results show that the combination of spatially accommodating the new user and inserting gaze in recorded discussions increases social presence and perceived attention, while merely spatially accommodating the new user did not. Further, our findings suggest that spatially accommodating the new user at a closer interpersonal distance did not further increase social presence or perceived attention. One possible explanation is that the interpersonal distance amongst the recorded avatars was already within the social zone. As a result, our approach for decreasing interpersonal distance may not have had its desired effect compared to situations where the interpersonal distance of the original recording is outside the social zone. Our results also revealed an inverse relationship between interpersonal distance and threat, where the latter measures participants' perceived levels of dominance and threat of the recorded avatars. There is therefore a risk of increasing perceived threat when one manipulates, specifically decreases the interpersonal distance of recorded social interactions. Contrary to our expectations, our results on gaze show that participants in the three transformed conditions did not look at the recorded avatars differently in terms of duration. In contrast to these results on direct gaze, our findings on mutual gaze matched up closely to the patterns we found for social presence and perceived attention. This suggests that social presence and perceived attention is closely related to mutual gaze as opposed to direct gaze. Finally, our results on gaze breakdown by avatars suggest that participants engaged in more direct gaze and mutual gaze with the two farther avatars across all conditions. We offered two explanations for this observation. To start, according to the equilibrium theory, an individual will tend to look more towards and engage in more eye contact when they're standing farther away from an individual. The second and simpler explanation is that users in VR may not feel inclined to move their heads in VR and thus resort to looking straight ahead as opposed to the two avatars on the side. Taken together with other findings, we outlined actionable implications for how practitioners, such as educators and virtual meeting organizers, can apply these techniques to other real-world scenarios beyond prompt-guided group discussions. For the scope of this presentation, I will be highlighting a selective few from the paper. To start, when presenting recordings of a VR group discussion, consider applying both proxemics and gaze transformations. This implication echoes past works demonstrating the benefits of augmenting synchronous social interactions, as our findings show that transformations of asynchronous social VR can also be beneficial to the user's subjective experience. Additionally, it is also important to consider the potential downsides to transforming proxemics, as lowering the interpersonal distance was related to higher perceived threat in our study. One approach for mitigating this risk is to reference the existing interpersonal distance and decide whether changing the interpersonal distance is appropriate for the given use case. Next, when deciding the spatial juxtaposition of the new user, consider employing mechanisms for directing user attention towards the periphery or placing avatars of greater significance near the center of the user's viewing perspective. This is because our results indicated that participants looked more at the two avatars standing closer to the center of their field of view if they look directly towards the center of the group. Finally, it is also important to consider the ethical implications when applying these transformations in real-world scenarios. Notably, VR users may not consent to their recordings being altered, and new users joining transformed recordings may not be aware of these manipulations and therefore be at risk of deception. Furthermore, altering the nonverbal behavior could also distort the original user intentions and lead to unintended downstream effects. While we mitigated these risks through obtaining consent, choosing discussion topics on hypothetical scenarios, and post-study debriefing, we see a need for designing consent models, selecting real-world applications, and curating content to systematically address these risks. In summary, we studied how users perceive asynchronous social interactions in VR, and further how transformations of nonverbal communication in recorded interactions influence user behavior. In light of the possibilities afforded by asynchronous social VR, we see opportunities for transforming recorded interactions to deliver an enhanced experience for real-world scenarios beyond prompt-guided group discussions. To learn more, please see our paper.